Welcome to today's webinar. As you all know, my name is Roshan, so I'll be introducing our speakers today and will be helping to facilitate the Q&A session as well. So it's my pleasure to introduce Dr. Elena, Research Fellow in Robotics and AI at the Center for Transformative Media Technologies at Swinburne University. Dr. Elena completed her PhD in Mechatronics at the University of Melbourne, and her research explores the intersection of robotics, AI, and the human-robot interaction and creative practice, which is one of the unique things. Her work focuses on how people can learn from, teach, and collaborate with robots through rich multimodal interaction with applications spanning collaborative robots, swarm systems, and interactive robotic experiences. So today, Dr. Elena will present on the topic titled Collaborative Robotics Through a Creative Lens. So really looking forward to the presentations and discussion today. And yes, and over to you, Elena.
Thanks, Roshan, for that introduction. And we'll just jump right into it. So as Roshan said, I'm going to speak about creative practices in robotics today. So what I want to take us through is discuss two applications that I've done. One's a multi-human, multi-robotic interaction, and the creative output of that and research was called the encounter. And then I'll also talk about movement as rational with a new project that we're currently working on across QUT and Swinburne, and that's called Moving with Robots. I'm going to discuss a little bit about a preference learning trust framework that was integrated into the encounter in that multi-agent experience to just illustrate how machine learning, human preferences can be incorporated into this practice-based experience and creative outputs, and then just finally talk about the learnings and conclusions of the works. So I think we're all aware of why we're all here, but robotic systems, as we know, have reached this level of maturity and accessibility where they're able to share spaces with human, and this is no longer exceptional, it's realizable. We are seeing them working well in tightly structured environments such as logistics, healthcare, and service settings. But when we consider this broader social and cultural and artistic context, the problem shifts fundamentally. In these settings, collaboration is not just about safety or task execution. Really, it requires this anticipation, shared intent, and mutual adaptation over time. Interaction is open-ending, meaning it's negotiated and behaviors unfold dynamically rather than being predefined. And you'll see that in this interaction down the bottom. It's quite fascinating because two of the users are collaborating together, the younger user with the older adult, and then there's a single user who's working by themselves. So these the interactions, we don't really know these social dynamics, how are they going to play out? So you have to have this level of online learning happening. A central challenge really is ambiguity in social cues. Humans communicate through movement, spacing, timing, and context signals that are often subtle and these situation and deliberately non-explicit. These cues are difficult for conventional robotic systems to interpret, yet they're essential for social coordination. This ambiguity is heightened in dynamic environments, such as galleries, public spaces, and care contexts and performances, where participants move freely and interaction emerges in real time. It's here we need robots to be able to extend their autonomy, the capacity to coordinate actions beyond a single targeted controller and adapt on the fly and remain responsive as these situations evolve. As interactions scale to multiple people, social dynamics become collective. Emergent behaviors arise as participants influence the system of each other. And in these contexts, trust and engagement, really develop on robots moving in ways that are legible, expressive, and socially situated. We are now at a moment where humans and robotic systems often work collectively or as a swarm or are approaching this meaningful co-presence, and realizing this demands not just technical solution, but creative engineering approaches to design frameworks, policies, and systems that allow the robots to function as participants within this shared social space. And this is really where creative practice becomes critical. As a as a situated, practice-led way of investigating human robot or human swarm. I may use the word swarm, the term, or multi-agent system, being a collective, and how they interact. So this diagram here is quite pivotal in a way of representing creative practice in engineering research, and it's an approach, it's through creative practice, not as an aesthetic or an add-on, but as a legitimate research methodology in engineering. What this diagram we see on the right is doing is it's framing that position. It places collaborative robotics at the intersection of practice-led research, and robot interaction and collaboration. The point is that collaborative robotics doesn't sit comfortably in just one of these domains. It emerges from the overlap. On the left, we see that practice-led research emphasizes inquiry through making iterative development, that institute trial and error and reflective evaluation. Knowledge is produced through doing testing and responding to real conditions as they unfold. And on the right, we see this interdisciplinary research brings together human-robot interaction, co-design and mixed methods, and social technical perspectives. And this recognizes that collaborative robotics operates within social, cultural, and technical systems, not just purely technical ones. And this is what this approaches come together through research, and this is where the innovation unfolds in human-robot collaboration and through engagement with people, environments, and contexts. I really just want to highlight that it's not just a technical problem that we're trying to solve in this practice. By bringing disciplines together, we're learning new ways of researching, open research, and creating this meaningful, shared, embodied social spaces that really lay the foundations in place for robotics. And that's where robotics and arts can meet through this practice and interpretation of open-led research. One really fascinating point is in Engineers Australia's their attributes. Creativity is on there, and something that's really important in our practice as engineers. So now, connecting robotics and art experiences provokes challenging research interpretation problems, requiring the unification of subjective and objective modes of analysis. And with interdisciplinary research, this is often a real challenge. Robotic systems excel under strict and clear performance metrics, whereas makers of artistic performance are often open to multiple interpretations of its success, such that translating an artistic vision into a robotic interpretation depends on clear language and shared frameworks, so that the intent, behavior, and interaction can be meaningful, communicated across the artistic domains. For the project The Encounter, we brought together a team of artists, archaeologists, and social scientists with roboticists to explore the tensions with to explore human-robot interaction through giant standing stones that had robotic carapaces underneath that moved sympathetically to your movement. And the aim was to develop a robotic system that was capable of operating through a sustained performance where the installation, without direct supervision, was able to remain responsive to human presence and behavior. And this required us rethinking autonomy, not just as technical robustness, but as the ability to engage meaningfully within a shared space. A particularly distinctive outcome of this work was the opportunity to observe human swarm behavior across diverse age groups and backgrounds. And these encounters are rarely accessible in conventional robotic research, yet they reveal how collaboration, interpretation, and trust emerge in real-world conditions. By inviting participants to become part of the research experience, also, this work was open new pathways for public engagement with robotics and STEM. And more importantly, it helps us understand how trusted interactions are formed, not through optimization alone, but through lived embodied interaction across technical, social, and cultural domains. This leads directly into the question of extended interactions and how we can design multi-robotic systems that can collaborate through humans, not just momentarily, but over sustained encounters. And part of going back to that practice-led research was really this cycle of going through a vision, having our interpretation, and then trialing that over time till we got that final work that was that worked as an artistic piece, but also worked to the researchers as something that they could understand, they could gather information on, and had some that really highlighted their research question. And for us, it was this sustained, extended interaction and trust. So for us to be able for the gallery exhibit to become a reality, we aim to design multi-robotic systems capable of successful extended collaboration with one or more humans during the context, during this complex task. And this work focuses on focused on extending human preference and decision-making models to capture trustworthy interactions involving multiple users rather than a single trained participant. The motivation was to support real-world adoption where diverse groups of people interact with robotic systems over time. So to achieve this, we took a holistic approach by modeling human swarm interactions across extended periods, and we instead of having the human is external to the system, we had them modeled in our behavioral dynamics, which was one unique element of it. As well, we looked at designing control strategies and cost functions that encoded the subjective group level preferences, allowing multiple users and robots to collaborate meaningfully. Here, trust became a central measure of success, guiding how interactions were evaluated, sustained, and adopted. Despite its importance, temporal reasoning and the influence of time in human judgment remain underexplored in complex extended cobotic tasks, as rarely expanded to group-based scenarios. So addressing this gap was a key contribution of the work. And I think we have here, so this is part of the experience of users interacting and engaging with the swarm. So that you can visualize what's happening as we talk through this. Now we're going to move into this trust-based measuring trust and the preferences and going into preferential learning. So it's the technical framework behind the experience. Oh, my apologies. So now we're going to begin by examining the role of human preferences and trust in human swarm interactions, where we know that the human preference is unavoidable in the interaction and how it behaves and lays itself out. So in the accompanying video we see here is a person interacting in close proximity with a robotic swarm. And what underpins a successful interaction in this context is not only the system's performance, but the human's intuitive judgment of trust. In this work, we adopted the working definition of trust that you see there, where successful human-swarm interaction therefore depends on collaboration across diverse settings and on the ability to learn and predict how trust forms and evolves during interactions. We use a preferential reasoning to understand how different swarm behaviors influence a human's observer's trust over time. And while prior work has explored trust as either a scalar or multi-dimensional quality, preference learning and individual trust models, most existing approaches focus on single users or short interactions. Trust formation within teams and groups, particularly over extended periods, remains less understood. So this gap is significant because trusted human swarm interactions are critical across many domains, including industrial robotics, collaborative search and rescue, caregiving, and interactive art, where you'll see our focus of this application, where systems must operate within multiple people, adapt to social context, and sustain engagement over time. So it is vital to understand how the design and operation of systems influence human perception and trust, as trust directly shapes the efficiency, quality, and success of the interaction. To support trusted human swarm teaming, we needed to extend existing trust models to really account for groups of users rather than focusing solely on individuals and tuning the controller to the specific individual. So this requires new metrics that capture how trust forms, diverges, and converges across multiple users. Two key concepts guide this work that we developed. One is distinctiveness, how unique an individual's preferences are relate to others in the team, and cohesion. And this is the degree to which individuals share preferences and expectations. I'm going to go over distinctiveness today and just give you insight into how we did that. Significant challenges arise because trust is inherently nebulous, subjective, and idiosyncratic. Different people interpret the same robotic behavior in different ways, making trust difficult to define and measure and predict. Most existing trust models focus on selected characteristic while omitting others and effectively prescribing a single notion of trust that may not suit all participants. So as a result, current approaches struggle to capture this meaningful features of trust required to inform the human-swarm collaboration, particularly over these extended interactions. So human preferences, as we know, were unavoidable in this. So what we did is we used a machine learning approach, which is the problem of inferring a rating utility function from expressed human choices. And this is being studied at large and called preference learning. And in this work, human observers acted as a comparator. So they, when we asked them to perform a series of pairwise comparisons, they responded to which of these two swarm behaviors do they trust more, and they watched a set of different swarm behaviors that made our foundational library for our interactions of our art piece. And from these responses, we obtain an individual's chronological ordering over these subjective instances, such that different swarm, for our case, these instances are the different swarm behaviors. And our goal here is to embed these preferences into a feature space that allows us to interpret and reason about behaviors of interest. One common approach to use is a support vector machine, which is a way of classifying those behaviors. And then those preferences induce a separating hyperplane. So given hyperplanes, so given a chronological ordering, we require a way to quantitatively represent an individual's preferences. So following Kingston's work, we assume a quadratic human comparison preferential model, which defines a distance-based trust measure over the feature space. So each pairwise comparison introduces a hyperplane constraint that separates preferred from non-preferred behaviors, forming a space. Collectively, these constraints define a bounded region, which we see here as this preference polytope, and this represents an individual's trusted behavior region. Within this region, there are different optimization techniques that we can use to find the optimal trust point. We use the Chebyshev center, which is the largest inscribable ball that can fit within that polytope. And this then providing a robust representative of an individual's preferences. Using this framework, we can now describe each person's individual preference polytope, and importantly, different individuals often exhibit distinct and sometimes non-overlapping preference regions. So we need to work out a way of how we can compare individuals. And this motivates our next step, extending this framework to teams and how we can interpret and negotiate group level of trust. So what we did is extending individual trust to team trust provided a way of us understanding how to team individuals based on similar trust profiles and analysing conflicting preferences impact on the overall team's dynamics. So here we consider the instance of laboured preferences, and this was how we developed our distinctive measure for the group, where for describing how an individual's trust towards a swarm differ from others in the team. So we determined this by analysing differences in individuals' trust preferences as perturbations from a common reference and quantifying the representative divergence for each individual. We used an optimization program to find a good trust while minimizing the perturbation in our Z. This was subject to the hyperplane constraints, where each individual's preference polytope is enforced by that constraint. And the optimization used a sparsifying property. The key output was this distinctive value for each person, where low distinctiveness means someone's trust preference aligns closely with the group, and higher values indicate more divergent views. By thresholding the value, we can cluster individuals with similar trust profiles and identify where disagreement is likely to arise. This validated this approach experimentally with a group of participants, and we compared this optimization against the baseline, which is the TPS HRI trust score, where individuals within certain TPS bounds also exhibited low distinctiveness. So overall, this provides a principled way to move forward with individual trust modeling to team trust modeling and grounded directly in preference data rather than imposing assumptions on trust. So now I just wanted to show you some videos of the interactions. So first we had over 150 participants in this space, and we moved from single users to, you'll see, multi-users in the space. We had the swarm, which was the giant robots, went up to I think 12 at one point. What was fascinating is 90% of the people who experienced the encounter recorded an increase in emotional state post-exhibit. So from this, we can conclude that trust and successful adoption leads to an increased emotional state. One fascinating thing that came out of this performance, and this is now doing full cycle back to that creative practice and also interdisciplinary research, is the choreographers and artists that we worked with insisted that we didn't give the user any instructions before they entered the space. We wanted them to explore the space and see how they would react and respond to these giant stones moving towards them. So instead of telling them what to do, we told them to, we just gave them a stone that they physically held as well, and they walked into the space. We needed them to go to the center of the space to then trigger the start of the interaction. And we used a spotlight, as you can see here. This is what they experienced. What was incredible is, I mean, in engineering, I would never do this without having the guarantees of knowing that 100% of the time the human was going to go to that spotlight. But it was incredible. They did. So there was something that was to them a visual cue, and they knew to go to that spot each time. So that was a learning experience for us too, trusting different practices and their techniques, and how we can give human participants cues that are nonverbal. And now I want to just talk for this last few minutes a little bit on moving with robots, which is a new project that we're working on at the CTMT lab and across at QUT. And this really reframes human-robot collaboration and this embodied and choreographic movement through practices. Instead of treating movement as an optimized output, we understand it as a relational process. So this is co-constructed through ongoing interaction between humans and robots. The methodology that we're using draws from dance practice, improvisation, and choreographic structures to explore shared navigation, proximity, negotiation, and coordinated action. This allows robots to participate in movement as partners rather than executing isolated actions. And at the core of this work, we've developed this SCORE, somatic choreographic ontologies for robot embodiment methodology. And this integrates three elements: learning from human movement demonstration, designing from relational dynamics, and evaluating behavior through live performance and rehearsal. And the key is through that live performance and rehearsal is also where that creative practice comes in. So together, this approach shows how creative practice can function as rigorous research infrastructure, producing expressive, legible, and socially attuned robotic behavior that cannot be revealed through laboratory testing alone. And finally, to conclude, this work shows that creative practice can function as a rigorous research methodology in robotics, not just as a means of communication or demonstration. By working through practice, performance, and making, we gain access to questions and behaviors that are difficult to surface through conventional lab-based approaches. And a key outcome is the recognition of embodied human knowledge as a vital resource for robotics, and human movement, perception, and interaction contain rich tacit information, and learning from this embodied expertise allows robots to interact more intuitively and effectively with people. We also see that trust in robotics is fundamentally relational and collective. Trust does not emerge from a single interaction, action, or metric, but is built over time through repeated embodied interaction, especially in shared social and cultural spaces. And looking forward, this research opens pathways towards embodied AI, relational movement learning, and deeper interdisciplinary collaboration. Future work at the Centre of Media at CTMT will continue to connect robotics, creative practice, and human-centered design to advance how humans and robots can move, collaborate, and coexist together. Thank you.
Thanks. Thank you so much, Elena. That was a very insightful one. Especially, it's great to see the technical aspect with a touch of creative in it as well. Really awesome. Yes, I'll now open the floor for questions from the audience. Anyone have any questions?
I've got one.
Oh, yeah. Oh, go ahead.
Hi, John.
Hey, with the sort of preferences of people, do you think they will change over time? I know your study didn't sort of look at that, but is there any indication that, you know, sort of people trust things in a certain way, but when they become familiar with them, that changes? So it's sort of not fixed for a person.
It's a great question. And I actually have done that. I didn't highlight it in this work because I just wanted to touch on it, but we looked at short-term memory.
Okay.
So the influence of short-term memory over time. So you could imagine we had an online estimator and we had weights to those preferences. So that if you're comparing A to B to C, you've seen C the most recent. So that's going to have a heavier weight than A and B on your preferential reasoning. But I think that is important. There's definitely a time aspect. And I suppose what I'm trying to highlight in this work is that preferential reasoning still is great for building blocks for human interaction that can extend to those type of things.
Yeah. Thank you.
Thank you. Great question.
I've got a question about your population study. So did you look at different ages or people coming from different backgrounds? Because largely the people in your videos looked quite cool and hip, right? And so, you know, I'm just wondering if it was, you know, engineers or if it was young people or old people, how that might change.
Michelle, that's a great question. I didn't, why I'm saying the young and hip is I didn't get access to the like written consent for the other people in the videos, unfortunately. I really pushed to have children. I was really curious about children and how they'd interact with the system. Turns out they really excite the system, so push it to the limits. And then as age, so the older you are, you tend to be a little bit more cautious. So it takes time to warm to the system. We didn't look at cultural, but we did. So yes, we did look at age and gender. And it's an interesting one too, that I would say through galleries has been great working, because you look at a lot of robotic studies. I was even reading a paper, I think from HRI 2026, that was highlighting most people that they do the studies on are male. So we found through the exhibit, we had, funnily, more females than males coming through, which was quite unusual, but also fantastic to tap into and get that community to engage.
Great. Any more questions? I just have one question. I mean, since you worked in both the disciplines, like the technology side and the creative side as well, I mean, since you have those interdisciplinary experience, did it change your perspective on how you approach a robot, like since you work on the creative side compared to a technical person, because you work with other researchers who are like completely from technical side as well. So do you see any difference there?
Yeah, I do. I think I mean, it has changed how I do my practice, I do think, because previously I would be extremely goal-based, and I want to know that cost. I want to know the exact system we're designing. I want to be able to put it into that control system. When you're working with different communities, you can't do that. So I think hopefully got the message across in this talk as well, is that for creative practice, you have to be open. You have to just listen to the other interdisciplinary workers, and over time it will evolve and such that you can limit and constrain that system to get your own goal in research. One really interesting point was, because I mean, working with archaeologists, you'd be like, why am I working with archaeologists? I've got these giant standing stones, this makes no sense whatsoever. But the archaeologists, they use LiDAR scanning and scanned these stones from all around the world. And they were speaking to the specialists who do that. And funnily enough, they kept coming back to this thing of collective stones, and people touch the stones. They have this real need to touch the stones. And when we first did our exhibit, we were insistent no one could touch it. We were just too worried about the OH&S, and we're like, no, this is insane. We ran the first day of the experience, and quite honestly, it was a disaster. Like, you weren't getting human interaction. There was just caution. It was like, oh, I've gotten too close to this stone. Oh my goodness, it's stopping. And you could see it the whole time. And then the archaeologist came to me and she said, Elena, everyone in my interview said that they touched the stones. We have to somehow have this malleable boundary such that they can touch them. So we did that. We reduced the boundaries such that you could touch them safely. And it was incredible. The experience went from something that wasn't fluid, that wasn't natural, to a completely fluid and natural experience. So it was interesting from that specialist taking on that feedback and trusting them and putting that in the difference.
Great. Awesome. Any more questions? No? All good then. Thank you again, Elena. Thanks for this insightful presentation. And thanks everyone for the questions and participation. So with that, we will conclude this seminar.
Thanks for having me.
Again.